Good morning. Yeah, so this is yet another fine morning, and today we're done. I'm going to discuss a topic with you on chemistry. I believe that you guys watching over there. I welcome you to this channel. You can subscribe so you don't miss on any latest updates. We're done. Okay. Yeah. Now, today we're going to speak about the atom. Yeah, the atom. And that's the first strand of inorganic chemistry we're dealing with today is the atom. Yeah, the atom. Now, the atom. This is not the first time that you're coming across such a word. I believe you've ever heard it. If it's not maybe from your friends, and maybe some classes that you've attended earlier. Yeah, and today we've done. We're also going to elaborate on this topic further. So, buckle up because we're going to be having a very fun time of learning this topic together. So, let's begin. Let's dive very fast in several times. Terms of essence. Now, the atom. The atom. You get that every element, okay, every substance is made up of something, and that's something that it is made up of is what we're referring to as the atom. In that, I'm trying to say that an atom is the smallest particle of an element, okay, it's the smallest particle of an element, and it even can take part in chemical reactions, okay, yeah, so it is the smallest particle of an element. So mark that, atom is the smallest. So despite it being the smallest particle of an element, it is also made up of some other subatomic particles, okay? Yeah, in that there are some other subatomic particles that make up the what? The atom, okay? And this one we will get to know it when we are coming to now drawing the structure of an atom, okay? And now the substances that are the subatomic that make up the atom are there. We have the protons, we have the neutrons, and the electrons. So these are the subatomic particles that make up the what? The atom. Okay. Yeah, those are the subatomic particles that make up the atom. And I said that we're going to speak about them, we're going to go deeper into them, we will be studying about the structure from an atom. And now, just to understand the structure of the atom, we have some scientists that they really worked hard in identifying the atom. Okay. Yeah, they really worked hard in identifying the atom. They did a lot of research, they did a lot of studies to come up with a clear explanation on the atom. And now this is whereby we are coming across some three scientists that really backed the midnight oil in this. And thereby we have the first scientist, John Dalton. So John Dalton became in 1808. Okay, in 1808. And his definition of the atom, okay, he said that the atom is the smallest particle of an element. Okay. But from his identification or from his findings, okay, on how an atom look like, okay, when we try to draw according to John Dalton, this is how the atom look like, okay, yeah, that's just the atom, okay, that's just the atom. So according to John Dalton, this is how the atom look like, and from his theory, he said that this is the smallest particle of an element, which is right, but he could not, from the theory, you could not explain the subatomic particles that make up the world, the atom. Okay, you see, like according to him, the atom was just like a marble. Okay, a marble. You know how a marble looks like, just circular and something in it. Okay, but his theory could not explain on the what subatomic particles that are present in the what in the atom. Okay, and that was in 1808 by John Dalton. So this was John Dalton in the year 1808. Okay, but later on when we are coming to after several years, then we come to 1911. Okay, and in 1911 we have another scientist that is emerging up, okay, trying also to explain on the structure of the what of the atom. Okay, and now this is arriving another scientist by the name of Ernest Rutherford. Okay, and according to Ernest Rutherford, through an experiment that he carried out, just a gold foil experiment, he was trying to explain that this atom, there is something that still exists inside this atom. Okay, he was trying to come up, okay, and prove that that atom is also made up of some other subatomic particles, okay, that are present in the atom. And now from his theory, he proved that inside the atom, okay, that in the atom we are having several dense positive charge, okay, a dense positive charge in the nucleus, and that is how we get the what? The protons, okay? Remember, in the nucleus. So in the nucleus, explains that there was a lot of positive charge in the nucleus, okay? In the nucleus, at the center, Yeah, okay, at the center. And now, being at the center, there was a cloud, okay, something like a cloud that was surrounding the what? The positive charge, okay. And now that is where we're having the electrons, okay. Yeah, inside that, yeah, they were just somewhere, but surrounding the what? Surrounding the positive charge, okay. And now this one is when you try to draw the structure of the what? According to Ernest Rutherford. That is according to Ernest Rutherford, this is how the structure of the atom look like. But we get that as time progresses by, we come across another scientist that he refines the work that was done by Ernest Rutherford. In that, this scientist, you see that according to Ernest Rutherford, you cannot explain on the energy levels, okay? You cannot explain on the energy levels. But now this is something that is being refined by another scientist who now comes up with a quantized energy levels in the atom, okay? Yeah, and this scientist that came with that is known as the Bohr, okay? Niels Bohr. So according to Niels Bohr, he said that in the atom, okay, atom is made up of the positively charged nucleus, okay? Okay, then now outside the nucleus, we are having energy levels, and in those energy levels, so now we are having the attachment of the electrons. Okay, so inside the nucleus, we are having the positive charge. Okay, and now we have energy levels that surround them. Okay, so then we are having that. We have that. Yeah, so that is according to Niels Bohr. Okay, according to Niels Bohr, he's the one that came with this in the year 1913. Okay, yeah. So for Niels Bohr, on the structure of the atom, okay, this is how he explained it. Now for him, he just refined the work of Ernest Rutherford. Okay, when you check on Ernest Rutherford's work, he could not explain the energy levels, okay? But now Niels Bohr comes up with the quantized energy levels that enables us to define well on the structure of the atom, okay? In terms of the allocation of the electrons, okay? Yeah, now that was according to the scientist that aided in the research of the atom. This was in 1911. So having John Dalton, that this one was how he described the atom. Then Ernest Rutherford, this was how he described the atom. Then Niels Bohr defined Ernest Rutherford's work and came up with the better, okay, a good description of the atom. Okay. Yeah, so that was how the origin of the atom. Okay. So the scientists that tried to describe on how it arose. Okay. Yeah. And now, once you've known on how the atom looked like, okay, we're going to dig deeper. We're going to know of now the subatomic particles that makes up the atom. Okay, yeah, remember the atom is the smallest particle of an element, but there is still some subatomic particles that makes up the atom. Okay, yeah, and now let's speak about them, the subatomic particles, the subatomic particles. I believe you've noted them already. That is why now we are having the number one, the protons. And number two, we are having the neutrons. And number three, we are having the electrons. Now, this is what we are going to talk about. Okay, the protons, the neutrons, and the electrons. Okay. Now, when you check the nucleus, okay, for example, for you to get a better understanding, or even a faster and easy understanding of the atom, just allow me to use one element, okay? Allow me to use, let's use sodium, okay? Let's just use sodium. And now, when you want to include the mass number, the atomic number, okay? Those are things that we are also going to discuss here. You have the mass number, okay? The mass number, the atomic number. And remember, we also have the protons, neutrons, and the electrons, okay? Yeah, now, when we're speaking about the mass number, the atomic number, okay, let's give you the atomic number. So the atomic number, it refers to the number of protons that are present in the nucleus of an atom, okay. The atomic number is the number of protons present in the nucleus of an atom. But now we are referring to the mass number. This is the sum of protons and the neutrons. Okay, the sum of the protons and the neutrons is what gives you the mass number. Okay, yeah, and I said that we're going to use the sodium. Now, sodium, relating the sodium, that is the formula for sodium, okay, Na, okay, Na, and now we're always having the mass number at the top, which is at 23, okay, and the atomic number at the bottom here, which is 11, okay, which is 11. Now you get that from this work itself, you can work out the neutrons, okay, you can work out the neutrons, okay. Yeah, I want to check on the protons, the neutrons, and the electrons. Yeah, and now from this, okay, of sodium, let's try to draw the structure of the atom of sodium, okay. Now we have sodium, we have number one, we have the nucleus, okay, we have the nucleus, okay, and in the nucleus are always having the protons and the neutrons, okay. And remember that the number of protons is the atomic number, okay, atomic number which you have here, so the protons will be 11, okay. And now you should also know that what is the mass number? It is the sum of the protons plus neutrons. And now if you are having the mass number to be 23, in that we can allocate the number of neutrons, okay, which will be simply the 23 minus 11. What do you get? 2, 1, 12. So the neutrons will be 12, okay, neutrons will be 12. And once the neutrons are 12, now we can also draw the energy levels to locate the electrons, okay. Remember, on the first energy level, we are having 2 electrons, okay. The second energy level is having a maximum number of 8 electrons, okay, which will be 1, 2, 3, 4, 5, 6, 7, 8, okay. How many are remaining? Now here, actually, we are having already 10 electrons, okay, but remember we are having them to be 11, which means we still have another extra energy level here, which will be containing 1 energy level to make it now the 11. So this one is sodium. And now if that is sodium, we are having the number of protons to be 11, neutrons to be 12, and you have the electrons. Now from this, you can get to know that the protons and the neutrons are always found inside the nucleus of an atom. Okay. But at the same time, I want you to note that the number of protons, okay, is equal to the number of electrons. In that, when you sum up all these electrons in the electron plan, you will get them to be 11, same as the number of protons, and that is what creates the balance in the atom. Okay, yeah, equal number of protons and electrons. That is what creates the balance in the atom. Okay, so remember that over here, these are the energy levels. Those are the energy levels, and inside here, that's where we have the nucleus. Yeah, the nucleus. So from this, you can see the structure of an atom. Simplified further. Okay, simplified further. In the structure of an atom, you're having the protons, you're having the neutrons, and you also have the electrons. Okay, and the electrons are found in the electron cloud around the nucleus, while the protons and neutrons are found inside the nucleus. Okay, yeah, and that one, I believe that now you also understand what is the mass number. The mass number is simply the sum of the protons and the neutrons. Okay, and now the atomic number, which is the number of protons that are present. And you should also know that the number of protons is always unique in every atom, and it is what enables us to identify an atom. Okay, yeah, in that when it is 11, that's just for sodium. Okay, hydrogen, it is 1, it is just 1. For helium, it is 2, it is 2. That enables us to identify that this is helium. That one is hydrogen because of 1. That is sodium because of 11. Okay, yeah, so it plays a very huge role in the identification of the atoms. Yeah, so I believe to that point you've understood on the theory of the origin of the atoms, how they explain, okay, the atom, the atomic particles that also make up the atom. Okay, so even maybe just work out also another example so that you can also get to just understand it deeper. Let me also do the same for magnesium. Okay, let's write magnesium. So for magnesium, we have the mass number to be 24 and the atomic number is 12. Okay, let's draw the structure of magnesium. We'll begin with the nucleus. Okay, there is a nucleus. Okay, and in the nucleus we have the protons. We also have the neutrons. Okay, and now for magnesium, the energy levels, it will be, we have 2. Okay, then 8, then 2. Okay, yeah, the first energy level will be having 2. Okay, the second will be having 8 electrons, and the third one will be having 2 electrons. Okay, so let's draw it. So you have the first energy level there with the 2 electrons. Okay, you have the second energy level there, which is having a total of 8, 5, 6, 7, 8, and the final energy level over there. Okay, which is having last 2. Okay. Yeah, so for magnesium, there is magnesium. So what is the number of protons? Remember, the protons is the same as electrons. Okay, the protons will be 12. Okay, and how about neutrons? For neutrons, we check the mass number minus the atomic number. Okay, so it will be 24 minus 12 equals to 1. So the number of neutrons is also 12. Okay, yeah, so this is the structure of the atom of magnesium. Okay, you have the protons and neutrons there, then you have the electrons. That is the structure. So I believe that when it comes to understanding the protons, neutrons, electrons, it is now easy, simply, and you can easily even explain on how it looks like. Yeah, and also now something that you should also get to know, even though later on you get to learn on the periodic table. Okay, on the periodic table, it is very good in the session for you to know the first 20 elements of the periodic table. Okay, and they will really help you even when you are drawing the structure of the elements that are found in the periodic table. Okay. Yeah, so just always remember that the atomic number is the same as the number of electrons, and it will help you in indicating of the energy levels. Okay, yeah, in indicating of the energy levels. So I also want you to understand that when you're drawing the energy levels, because we are going to now go deeper in drawing of the energy levels. Now, once you know this, you don't forget to know of when it comes to drawing the structures, okay, but now we'll be putting them in terms of the orbitals, okay, in terms of the orbitals. And now when you're referring to the orbitals, we're having the s orbital, okay, we also have the p orbital, okay, and we also have even the d orbital. But now at this level of studies, we're only going to do the s and p orbital, okay, the s and p orbital. Now, in knowing the orbitals, you should know that what is the maximum number of electrons that can be carried in an orbital. Okay, and remember that we're going to discuss on the 2 orbitals. That is number 1, the s orbital, and the p orbital. So the maximum number of electrons that can be carried in the s orbital is 2 electrons. Okay, while the maximum number of electrons that can be carried in the p orbital is 6 electrons. Okay, now sometimes you can be told that put the structure of magnesium, okay, in terms of now the orbitals, okay, in terms of the orbitals. Now this structure is drawn, okay, but now you have to put it in terms of orbitals. So how are you going to do that? Okay, let's work out on some examples for us to understand the s and the p orbital. Okay, let's try working out, for example. Let's begin with the one for sodium. Okay, the one for sodium. Now when you check on sodium, this is how the structure looks like. Okay, this is how the structure looks like. So remember that in the first energy level, it is carrying up to 2 electrons. Okay, the second energy level is carrying up to 8 electrons. The third energy level for sodium will carry only 1 electron. Okay, only 1 electron. Now let's put that one for sodium. For sodium, it will be, so the first energy level you have 1 s, okay, 1 s, and how many electrons are carried there? You have 1 and 2. Okay, 1 and 2. So you write the number of electrons as a power to the s. Okay, so 1s, 2. And this one means it is on the first energy level. Okay, the s orbital is having a total of 2 electrons. Okay, yeah, let's go to the second one. That's the first energy level. Now the second energy level. The second energy level will be having, so we have 2 s. Okay, s. So remember that the second energy level is having a total of 8 electrons. Okay, 8 electrons. Now the first 2 electrons will be in the s orbital. Okay, so it will be 2s, 2. Okay, and at the same time we will be having the p. So the remaining electrons will be on the p orbital. Okay, so it will be 2s2, 2s2, 2p6, with the total of 6 electrons. Okay, yeah. And now we go to the next, the last energy level there. We have the last one there, which will be on the third energy level. Okay, so it will be 3. So since it is 1, it will be on the s orbital. Okay, it will be 3s1. It will be 3s1. 3s1, because it is one electron on the last energy level, which is on the third. S orbital, the electron is 1. Some is just 1. So I believe you see how that is coming, right? Yeah. So this is the electron configuration in terms of s and p orbitals. Okay, in terms of s and p orbitals. Let's work out the one for magnesium. Okay. So for magnesium, we have the first energy level. Okay, we have the s orbital. Okay, so we have 1s. How many electrons are there? 1, 2. Always mark that the first energy level, the maximum number of electrons it can carry is 2. Okay, so we have 1s2. Okay, and the second energy level is 1, which is having a total of 8 electrons. Okay, it will be 2s2. Okay, which is the first 2 electrons, and now the remaining electrons will be on the p orbital, which now be 2p6. Okay, p6. And now the last energy level, which is this outer one, is on the third energy level. It will be 3s2, because remember now 72 electrons on the outer energy level. Okay, so we make that 3s2. Okay, 3s2. So we're trying to work out the ones for the examples that we did earlier. Okay, so maybe we can try out for a simpler element. Okay, for example, carbon. Okay, so note that the atomic number of carbon is 6. Okay, let's do the structure of carbon. We have the nucleus showing the protons and the neutrons. We have the first energy level there, that is having 1, 2. Then the second energy level will be having 4 electrons. So 1, 2, 3, 4. Okay, let's draw the structure. What will it be? So for carbon, we'll be having the first energy level will be the 1s carrying 2 electrons. Okay, then now the second one will be this one. So having the first one will be 2s2. Okay, and 2p. P will be having the remaining 2 electrons. Okay, so we'll be having 1s2, 2s2, 2p, 2. When you add them together, you find 2 plus 2 plus 2, 6. To give us the 6. For magnesium, when you add the 2 plus 2 plus 4 plus 6 plus 10 plus the 2, that is 12. Magnesium, you have the 12 as the atomic number. For sodium, 2 plus 2 plus 4 plus 6 plus 10 plus 1, 11. So for sodium it is 11, the atomic number. So it is just that simple. Okay, it's just that simple. That is when now you are doing the configuration using the p and the s orbitals. Okay, and using the p and the s orbitals, that is how it is done. Yeah, so it was just that simple. So I believe you've really had a wonderful learning lesson with Teacher Dan, and we will just stop at that. So see you in our next lesson. We're done, and don't delay. So bye.